Alright, class, today we're going over exhaust gas recirculation. Now, the purpose of gas recirculation systems, or EGR, are to reduce NOx emissions and to increase thermal efficiency. Now, out of the engine block comes the exhaust. Some just comes out the muffler because if all of it goes through back into the system, no air would be added, therefore the engine wouldn't work. So through the engine control valve, only a certain amount of the exhaust comes back in. Now, this gas is inert, so what this does means it does not burn. Since it does not burn but goes back into the engine, it dilutes the amount of air that comes in. Reducing the intake mixture of air and fuel, it reduces the combustion temperature inside the engine. This reduction in temperature lowers the amount of NOx emissions coming out. Nitric oxide requires a temperature of 2,500 temperature Fahrenheit to form. Now, additionally, from the exhaust leaving the engine with less emissions, it also lowers the temperature of the exhaust leaving the system. Therefore, it reduces heat loss and helps thermal efficiency. After the exhaust gas recirculation control valve comes the steel wool filter. Now, that gets rid of the smoke coming from the exhaust to clean it out before it comes into the intake mixture, and then it is reduced to mix with the air and the gas that then enters the engine block again.
Do you think that the internal combustion engine has reached its peak? And if so, what other engine would you suggest using in the future?
It has reached its peak. I believe that gas turbine engines are the future.
Most internal combustion engines average around 30% thermal efficiency. What is the main problem in overcoming this huge inefficiency?
Now, there are a lot of problems with internal combustion engines, but the main problem is the exhaust is too hot.
The exhaust is too hot.
For EGR, the externally cooled exhaust gas recirculation, a small quantity of exhaust is diverted from the main flow of exhaust and passes through a special heat exchanger that coolant flows through. A valve system mixes the cooled exhaust with the fresh air in the intake. The recirculated exhaust gas hinders the chemical reaction, which causes nitrogen oxide to form during combustion. Less nitrogen oxide is produced in the combustion chamber. The inflow of returned exhaust is continuously adjusted by a flap controlled by compressed air at the entrance to the exhaust cooler. In the DO8 engine series, the maximum gas recirculation rate increases to 30% for the Euro 5 limit values. Regulating the recirculation rate based on need makes a considerable contribution to minimizing fuel consumption. The externally cooled and controlled EGR is a key technology for the development of low-emission MAN engines in the future.
Combining hydrogen gas with natural gas in the engine, emissions of CO was significantly lowered, but there was slightly more NOx released. Methane and methanol also help reduce combustion irreversibility, which leads to a higher engine efficiency. Exhaust gas recirculation can help to reduce engine emissions by reducing the amount of oxygen intake. This lowers the temperature, which lowers the emission of nitrous oxide.
Lower temperature engines are also more energy efficient because the heat lost during the emission of gases from the transition from system to surroundings is less. Overall, internal combustion engines have become almost as energy yet cost efficient as possible, so employing a new type of engine in cars, such as gas turbine engines, would further help to increase energy efficiency.